Hi, everybody. Just a quick introduction. I've been doing software for some time. I'm CEO of a company called Represent. We make API design tools and offer services related to that. And I'm easy to find online, so feel free to get in touch with me anytime. So, quick overview. I'm going to talk a little bit about domain-driven design as it relates to APIs. I'll talk about some of the characteristics of REST and event-driven architectures kind of emerging in our world with microservices and lots of reactive architectures kind of popping up all over the place. And then how this relates to domain models in domain-driven design. So kind of tying these things together and trying to figure out how they fit. Domain-driven design is something that really appeals to me as kind of a generalist because I'm not strictly a coder. I've done a fair amount of coding, but I really like to think about systems in the context of a business or an organization or an ecosystem. And there we need to really be able to speak language that's not strictly technical. So domain-driven design, the spirit of it really is about aligning software systems with the natural way that we think about the world in which we're building the software. You know, the problem domain or the business domain that we're building the software to improve or address. So there's a number of patterns. It's kind of a system of practices with lots of different aspects dealing with the organizational challenges, dealing with technical challenges. There's a couple of key things that I wanted to point out. One of them is this notion of a ubiquitous language. So the ubiquitous language is kind of what emerges out of this analysis process when we try to formally model the business domain. Ubiquitous language becomes the vocabulary that we use when we do this successfully. We use it consistently in our conversations, in the software itself, in the interfaces, and in all kinds of design discussions. So this is really the key to unifying things. But a ubiquitous language really only exists within a bounded context. So we don't expect this model to apply universally everywhere. We try to make it intuitive. We try to make it applicable outside of technical boundaries. But the reality is we are focused within a certain context, and that's where we define this ubiquitous language. And it also includes a whole collection of software patterns that are used in order to preserve this ubiquitous language and make it easy to work with. Try to keep as many of the technical concerns separate from the primary discussion of the business, the events, and so on. So a few of these things that pop out. You know, one is the notion of an entity being something that has its own identity over its lifetime, independent of its state. We have aggregates, which are really collections of entities and value objects that are arranged in a way with a kind of encapsulated boundary around it. So the idea of an aggregate is that it maintains its internal consistency and it's only accessible from outside through one designated object called the aggregate root. There's a number of these other principles and patterns that apply here, but just mentioning a couple of them that are key to understanding and to practicing domain-driven design. So this is sort of my ideal architecture for APIs, especially if you're in an organization that's not just creating a single API, but you're maintaining a whole catalog or portfolio of APIs. The idea of a domain model is it's incredibly powerful in the way that it can bind them together. Because developers don't really use APIs in isolation. Developers use APIs in combination. And so the domain model, when we create it and we consistently use it across our APIs, it means that our APIs are more interoperable. They're easier to use in combination to solve problems. And that's why we focus here, and we've developed a lot of core technology at Represent and practices and patterns around this. So one thing about REST is that state is the S in REST, and so it's naturally concerned with the state of resources, or the state that's encapsulated by a resource, and the representation of that state on the wire. So it's really, when we think about a resource in REST, it's addressable. It has a URI or some other kind of unique identifier. It often, usually I would say, encapsulates some kind of state, and it means something to the business domain. And clients and servers in REST, they communicate by exchanging representations of that state. So the representation is important, at least at the communication layer. And we have this uniform interface for state-based operations with standard get, post, etc. And client and server have distinct roles. So client-server is actually one of the constraints of REST. So that's important when we think about REST and how it contrasts with event-driven architectures. So microservices, has anyone not heard of microservices? They're kind of unavoidable, right? And the term means different things to different audiences. But I think of them as really being things, first of all, the whole architecture is being driven by the need for more agility and massive scale, right? So we see that it's emerged out of companies like Netflix and eBay that are just doing incredibly large numbers of transactions and things happening all the time. And there's a need to separate things and scale them independently. So it's about componentization, right? Unlike SOA, which is about centralizing things, this is really about breaking things down into components and doing this form of extreme coupling where everything is highly autonomous. So they're highly concurrent, and usually they embrace an eventual consistency. They're not trying to preserve consistency in real time in the ACID transaction sense. Events are going to ripple through the system and eventually land at a consistent state. So events are primary in a microservices architecture. And each service is really responsible for maintaining its own current state by processing a stream of events that are of interest within that service boundary. So microservices really is an example of an event-driven architecture. Sometimes they're called reactive architectures. And we define an event as something of significance that occurs within the business domain. Like, for example, you've got an item added to a shopping cart, price is updated, payment approved, etc. Events are immutable. So we don't think of events as something that can be deleted from the history. That would corrupt the entire history. Once an event is created, it can't be undone. It can only be superseded by another event that could change state. Events are transmitted by a publish and subscribe protocol. So as the person as the service that's emitting an event, that's posting an event, I don't necessarily know who's going to listen to it and what they're going to do in response. And likewise, as the consumer of an event, I don't really know or necessarily care who published it or where it came from. So there's a decoupling between event publishers and event subscribers. And they're usually, we assume in most large-scale event-driven architectures, these things are going to be processed asynchronously. Something that's important is that there's a separate notion of a command. A command is not exactly an event. It's something that could potentially change the state of something, but it's neither a state nor an event. Commands can have their own data model separate from the entity that they're requesting to update, and a single command could create multiple events. It doesn't even necessarily have to change something. Really, the processing of the command could result in a state change quickly or eventually or never. Just comparing commands and events. The command is something that conveys an intent. We could kind of think of it as a request. whereas the event describes something that already has happened. So we would state the event really in the past tense. A command is targeted to a single receiver. Command is something I issue to someone who I expect to be listening. With events, anyone can listen. Commands are one-to-one, and events are really one-to-many, or one to some unknown number of listeners. One of the patterns that comes up is CQRS. I mentioned before that a command can actually have a separate data model. So rather than have a single data model that's used everywhere, what CQRS does is it allows us to separate the data that we pass with a command from the data that we receive when we're interested in knowing what's the current state of something. Because those two, the needs of the user interface or the needs of a service in those two contexts can be different. Event sourcing is another pattern that we find in reactive architectures. And this is where we kind of take the idea of events to the logical conclusion and say, really, if we want to know what's the state of the data, that is really the cumulative result of processing the entire history of events related to this entity. So we don't even really store entity state as the primary storage. We might cache it, we might compute it like a materialized view, but we don't treat that as the primary thing. The primary data that we store is really the full history, the full stream of events that affect a certain entity or aggregate. And event storming is a workshop exercise. It's a kind of emerging, and I think still experimental process of getting a group together and understanding the full event lifecycle. And it uses sticky notes, and they're color-coded. And it's pretty interesting. And it's another way, really, of constructing a domain model that, again, just embraces events as the primary thing of concern. So this kind of gives rise to this question: what do we think of when we're trying to construct a domain model? What kind of information belongs in a domain model? I mean, if the goal is to describe the business context that we're building software for, what should it primarily be concerned with? Well, we know we can create data-focused domain models. Everybody's seen UML diagrams and other similar ways of describing a domain, but that tends to ignore the event lifecycle. And behavior, when we're concerned with behavior, we kind of model that separately as part of a service model. Sometimes this is called an anemic domain model because it just leaves the behavior out and it becomes just about data or state. We can do an event-focused domain model too. That's another thing we can do. And if we're not paying adequate attention to data, or we're not making an attempt to define data in a way that goes across the entire event stream, then we could really have a data mismatch between services. We could develop one service with one way of describing an order or a shipment or whatever it might be, and then other services that use completely different vocabulary. So it doesn't really achieve that ubiquitous vocabulary that we're after. The other thing is that when we look at these event processing architectures, something at some point is going to go wrong, right? And if we don't have any high-level picture of where events are, where events are being created or posted, published, where they're being consumed and how they're being responded to, it gets pretty difficult to diagnose problems that can happen in event processing and know how to respond if something goes wrong or where to look. So the idea of an eventful domain model, and by the way, I did kind of get sneaky here and change the title of the presentation because I like the word eventful a little better than event-rich. But so I'm calling this an eventful domain model. And I should say that there is no one view or one format that I've found or that I've seen yet that really adequately captures everything. So for now, we can really think of an event domain model as a composite of these two things. And the idea is that through our analysis process, through our domain modeling process, we're going to do some switching back and forth between perspectives to get something that adequately captures all of these different aspects. So the big question, I mean, most of us are somewhere on the REST adoption curve, right? We're either doing REST full time and we're REST ninjas, or maybe we're in a large organization that still has a lot of legacy services. We're embracing REST. We've done it successfully in some cases, but still finding our way. But most of us are still at a point where we've got REST pretty firmly in our minds, and it's something that we use and that we think about in our API design paradigms. So how do we process this whole event-driven thing, given our REST mindset? What do we need to do to adjust to this world where events have now become so important? One way that we can think of them is they are resources, but they're immutable resources. So what I've described here in this diagram is something called an OrderChanged event collection. In fact, let's start over here. Let's just look at the OrderChanged event resource. So it's got this URL /OrderChanged events /event ID. It has an OrderChanged event schema or data model that's associated with it. So it's going to have an event ID. This is a simplified kind of quick and dirty model of what an OrderChanged event might look like. It would have all the expected identifiers. It would have a timestamp and possibly something like a delta, something that describes what properties changed, what they changed from, what they changed to. And if we had a resource like this, we'd probably only have a get method. We definitely don't want to allow people to delete events, because once they exist, they can't be removed from history. And we don't want them changed either. So individual events are immutable. And then we'd have a collection of these where we could look at the whole history of events or possibly filter the list for certain types of events that we're interested in. And this one could have a post where we'd post a new OrderChanged event to the history. So we actually can represent events in REST. It's not really hard. But if this is our entire resource model that concerns orders, if it's just a stream of events, this is probably much too granular for the kinds of things that we would want to use a REST API for. I mean, if I'm querying an order service and I want to know the current state of an order, I don't want to have to go through the entire history of events to figure out what the current state is. So we can think of the events as really secondary resources that are created off of a main order object resource here. So the main primary order object is going to have the current state. It should be read-only, possibly, right? There are different ways to factor this, right? But the way that I'm showing here is that we'd have a read-only order object. It would have a set of changes shown here as a hyperlink where we can navigate downward to get the history of change events. So if we go this direction, we could think of this as sort of a unified resource pattern that gives us the current state and also gives us events. The readable, the get methods would be available to any API client, but the post event that adds events probably is only available to an event processor. There's some design issues we need to be concerned about. So synchronizing the primary resource with events. So if somebody posts an order change event, we do expect that to change the state of the order object. And if we do allow a direct patch or put or something else that changes the state of the order object, then that also has to update in the other direction. that would have to post an order changed event so that these two are consistent. We also have to find some way to provide access to events if the primary resource, if the actual order gets deleted, there still needs to be some way to get to its event history. And I won't talk about specifics there because I think I'm just a little over time. But a couple of questions. I mean, one is, do we need this, right? Do we actually have clients in our services architecture that need convenient access to the current state of this resource? If you don't need it, obviously, maybe a REST API just doesn't even belong in this particular microservice. And with writing, yes, we can support event posts in this way, but is the REST API the appropriate place for this? Do we need this to be RESTful is really the question. So, some alternatives. I mean, if we do want it to be RESTful, we can employ webhooks, WebSub, or one of these other protocols for event notifications. And so these are nominally within the REST paradigm, but they're not native, I guess, to REST. They're sort of add-ons. The other thing that we can think of is event processing as a separate channel, right? So we can think of the microservice as something that exposes a REST API, but also consumes events and uses those events to update the state of aggregates or entities within its boundary. So where we've got a really heavy demand, we're doing lots of event processing, and we don't want this to contend with the REST API. We want to do it asynchronously. Then this might be a more appropriate kind of architecture, where we just separate the REST API from the event processing aspects. So I'm out of time, so I'll stop here. But thank you.